Alright, so the length of an arc is different from the measure of the arc. The length of the arc is how long would a piece of string be if I had it laid out on that circle just on the edge for that arc. So we're looking for the measure of the curve is really measuring the actual curve itself, where the length of the arc is measuring the length of the line segment that would be created if it were laid out straight. So an example of something what this would look like is if this were a whole circle, the two blue lines were radii, that pink line right there, the length of that pink line would be what we're looking for when we're looking for the length of an arc. Alright, so the questions you're going to have, what they're going to look like are things like, what is the perimeter of a figure that has part of a circle? Or what is, if they're not asking for just arc length itself. The length of an arc is a portion of the circle's circumference. So the way you're going to set it up is like a proportion. So when I think of this, I always set it up as part over whole, and then arc length on one side, on the left side, and degrees are always on the right side. So you're going to set up your arc length is to your circumference what your angle measure is to the measure of the whole circle, which is 360 degrees. So your arc length will always go on top of circumference. So you've got your arc length measurements in the left-hand column. Your part's always going to go on top of your whole. Your right-hand column is always your degrees. So your part of your degrees is your angle, your arc measure. Your whole of your degrees is 360. Part of the circumference is your arc length. Your whole circumference is the whole circumference of 2 pi r. So you always set it up with arc length over circumference equals angle measure over 360. You're going to cross multiply and solve for what you're missing. So most of the time you're going to start off missing your arc length, but sometimes you may be asked to find the circumference. So you would put an x down here in place of the 2 pi r and plug in everything else. You may be asked to find the radius. So you would have to set it up just like this, except plug in your arc length and your measure of your angle, or excuse me, measure of your arc. You may be asked to find the measure of the arc and you're given everything else. So whatever you're given, you plug it into the appropriate place and then you solve for what you're missing. So an example that we have over here would be find the length of the arc. So it tells you that the radius is 7 and it tells you that your angle is 80 degrees. So I'm missing my arc length, so I'm going to put an x on top. I can figure out my circumference using 2 pi and then I'm going to plug in 7 for r. That's going to equal my angle measure or my arc measure. Now it didn't tell me 80 degrees was out here, but that's a central angle. So I know my 80 degrees goes here and my 360 goes right there. Now to get x by itself, I'm just going to multiply both sides by 2 pi times 7 or 14 pi. So I'm going to multiply this over here by 14 pi. Multiply this over here by 14 pi. This cancels out. So x is going to equal 80 over 360 times 14 pi. So I'm going to plug that into my calculator. So I'm going to press my fraction button to get my 80 over 360. Come out of the fraction, multiply that times 14 pi. So it's set up in my calculator exactly as it is on my paper. I'm going to hit enter and I get 28 pi over 9. If it asked you to round to the nearest whatever decimal place, let's say it asked you to round to the nearest tenth, so it's approximately 9.8. Now they'll usually have units here. Let's say that was inches, so your inches would go here. Please understand that 28 pi over 9 inches is the exact same thing as 9.8 inches. So 28 pi over 9 is not some random set of symbols. It actually is a number. It represents almost 10 inches long. Alright, so one that might look a little harder, a little more challenging. Let's pretend that's a real square right there and that this is half of the circle. I can't draw as usual. Alright, so this is my radius of this what would be circle. So my circle would be this space right here, but it's asking for the arc length of this. Now, if I were to connect the dots, this would be half of a circle. So I have two parts of the perimeter I need to figure out. I need to figure out what these three sides are added to the length of this arc over here. So if this is 5, then the entire length of the diameter would have been 10. If this whole thing is 10, then I know this part's 10, and this part's 10, and this part's 10. Alright, so that takes care of that. I've got 30 already. plus whatever this arc length is. So now to figure out arc length, I'm going to set up the same way I did up here. I'm missing the arc length over the circumference. I'm going to set that equal to 180 degrees, because that's half a circle, over 360. To get x by itself, I'm multiplying both sides by 10 pi. So I know that if I use my fraction button again and I do 180 over 360, now if you can look at that and go, well, that's just 1/2, that's fine too. All right, times 10 pi, well, that's just going to equal 5 pi. So 30 plus 5 pi is the answer. If we need, again, if it's asking for some form of decimal, I can add 30 to it, and it's 45.7. And that would be a version of a harder problem. The other thing that we need to talk about is area of a sector, which is really, really similar to arc length. So now instead of talking about the length of that arc, we're talking about the area of the shaded region. And a sector is a part of a circle that's created by 2 radii and then the arc. So that is a sector. So a slice of pizza would be a sector of the circle. So the questions that will be asked will always be, find the area of the shaded region. It's not always going to be this pretty or this easy looking, but find the area of the shaded region is what it's always looking for when that should make you think area of sector. All right, so the area of a sector, it's set up really the same way. So you've got your area of the whole circle, or area right here, and degrees right here. So instead of length, now I'm talking about area. So I'm not finding the arc length anymore. I'm finding this whole area of the shaded region. So instead of circumference, I'm going to put the area formula. So the area of the sector, or the part over the area of the whole circle, is equal to the angle measure over 360 degrees. So it's really a similar setup. So if I were to do a problem like, let's do number 9. If I were to do a problem like number 9 right here, I'm going to slide it way up so we can just see it. All right, so I know that my radius is 10, and I know that my angle, my arc measure is 60 degrees, right? So now if I go back and I look at my formula, it was area of a sector. So area of a sector is the small part, or the part of it, over area of the whole circle, which is pi r squared, equals my arc measure over 360. So I have a radius of 10 and an arc measure of 60 degrees. So I'm literally just going to plug in everything I can, and I'm going to have, I don't know what the area of the sector is yet, over pi times 10 squared equals measure of my arc, which is 60 degrees, over 360. So again, to find x, all I have to do is multiply both sides by 100 pi, because 10 squared is 100, and that's just pi. So I'm just going to multiply this side by 100 pi. When I do that over here, these go away. So in my calculator, use my button, not that button, and I'm going to say 60 over 360 times 100 pi, and that equals 50 pi. Slide this up a little bit. 50 pi over 3. Okay, again, if it asked you to round to the nearest, now that was in, if I go back and look, that was in inches. So I have to say inches, but it's square inches, so it's inches squared. So again, if it asks you for round to the nearest whatever decimal, I'm going to use that button right there to change it to decimals, and I get 52.4. So it's approximately 52.4 square inches. So that would be an example of an area of a sector problem. They do get more complicated with problems like these. Really though, this problem is the area of a whole circle, which is the big circle, and you subtract off the area of the small circle, or the area of the square and you subtract off the area of the circle inside. The area of the whole circle, subtract off the area of the square. So they do get a little more complicated, and we'll demonstrate those more in class.